what it is, what's going on, what it is. Check this out, y'all. Hey, scientists at hand, you know what I mean, self-scientists. Not trying to discover, patent, anything like that, you know what I'm saying? Not trying to build anything for other than personal use, information, findings, and stuff like that. Seriously, though, because self must do for self. You understand? Corporations and businesses starts infringements on every damn thing. You know, really, for real, for real. You know, you stumbling onto something that creates energy or makes you feel better, you can't impose it and say you found some type of healing or anything, because most want to adhere to it, and then you got to go through what is called corporate, you know, agreements and all this type of shit, and no one needs to be agreed upon anything, especially if you're studying for self. You know, you're working in a laboratory on self. You're trying to simply harness your ability and your thoughts to maintain and sustain the best way possible through natural elements and things of that nature to enhance you. Is that wrong or anything? Nevertheless, I'm going to speak upon superconductors. All right, we know the skin is a semiconductor. Everything is a semiconductor basically, or it's a dielectric, meaning that energy can't travel through it. Now, I'm just going to throw some things at you real fast, because I got a lot that I want to show you. But I like to tell people so they can come up with different analogies or get started on whatever they want to, you know, put in place, you know, nevertheless, or can utilize in any way. Now, here it is. Keep in mind that when we see a wire running, a copper wire, or, you know, an appliance cord, we think when we plug it in, the energy comes through the cord, but actually the energy rides on top of the wire. It rides on top. It rides on the outside of the wire, not in the inside. It rides on the outside. All right? It rides on the outside, not in the inside. All right? Now, check this out. So, that's why they say chi, energy, is all around you. Now, I'm not saying it's not in you, but remember, reverse psychology. All right? Now, check this out. Just keep this in mind. These are just tools to utilize in your method of energizing. All right, listen. So a superconductor. I used to always say that, but I never figured it out. What makes a superconductor? How does a semiconductor become a superconductor? Right? How does that happen? Well, a superconductor, I had to write it down, is high temperature ceramics. Did you hear that? I said ceramics. Silicon Valley. Ceramics. Silicon Valley. Ceramics. Alright? Ceramics. Pottery. You know all those pottery things that they showed us? Remember in Egypt they put their organs inside of this pottery, this ceramic type of conductor, and they also showed you Babylonian batteries looking exactly like those canopies or whatever it's called that held the organs of the body in the Egyptian temples. Looks almost like a battery. Nevertheless, with organic dialectic inside of it. Listen to this. And that's not far-fetched, because there it is right before you. Just look it up. So nevertheless, a superconductor is high temperature ceramics. Ceramic, what is a ceramic? A ceramic is an alloy. Now, funny they say alloy. Alloy is a metal. Once again, they said ceramic is an alloy, meaning it's a metal. Yeah, check it out. So ceramics is an alloy of oxides. All right, oxides, meaning that, well, let me go on. All right, real quick. I'm going to make this fast before this time limit go. But ceramics is an alloy of oxides, all right? I can't pronounce this word, but it's yttrium. Yttrium. and then barium, B-A-R-I-U-M, and copper. All right. Oxide means, let's just say we got iron oxide. Oxide, anytime you hear oxide, that means oxygen. It's nothing but iron exposed to oxygen, making rust. So iron oxide is nothing but iron exposed to hell amounts of oxygen that causes rust. So red iron oxide is red iron rust dust. All right, rust. All right. So when you hear that ceramics is an alloy, meaning it's a metal, correct. Ceramics is a alloy of oxides of yttrium, whatever that is. Oxygen exposed to yttrium brings on the rust or whatever comes off of it, right? Barium, oxygen exposed to barium brings up on the alloy of the rust that exposes from the barium. The copper exposed to hella oxygen oxidizes the copper, mixing that green substance that comes off. All right, and that's when we wear copper, we get that into our energy, right? That surrounds and rides on the outsides. All right, now listen. So when you get the oxidization of yttrium, all right, just use that as a word. Okay, Y-T-T-R-I-U-M, and barium, B-A-R-I-U-M, and copper. All right, so now it's a ceramic, is an alloy. Now you know why they call it an alloy, because it's metal. It's three different metals that has been oxidized into particle or granules. You know what I'm saying? You know how rust look, it can be chopped up. All right, so copper, you know how that green stuff, it can be chopped up. Now it's a powder. Now you have metal powder. All right, metal powder copper, barium, and yttrium or tritium. All right, now you mix those three and you have what's called ceramics. It's a superconductor. Now the superconductor is what makes it a superconductor? Ceramics, these potteries, all right, this clay, earth clay. You can even dig in the ground and find clay that will have all of the essential minerals as the yttrium, barium, and copper. All right, you might want to add some copper if you're a true scientist and you think the alchemy that you have in your mind assists and can consist of helpful thought patterns to maneuver and manufacture whatever it is you would like to manufacture in your health management, and only that. Nevertheless, so a superconductor is a ceramic, okay? Because the ceramic, why? Because the ceramic loses all of its electrical, yes, the ceramic loses all of its electrical resistance at a relatively high temperature, meaning a cold temperature. Remember, a cold temperature. Copper does not become a superconductor unless it's under cold temperature. Antarctica, keep it in mind. A superconductor, meaning like copper wire or platinum, does not become a superconductor until it is froze under high or low temperature, very, very cold, very, very low temperature. All right. Now you could use liquid nitrogen. Now I'm gonna show you something to make a neodymium magnet levitate. All right, and how it's levitating? It's levitating over, guess what? A superconductor, meaning a piece of ceramic. All right. Ceramic is levitating, listen to me, it's levitating over a piece of ceramic made from yttrium, barium, and copper, but not in a metal fashion, yet it is metal because it's ceramic. Ceramic becomes a superconductor because once it is froze or freezed, all right, like flash freeze with the liquid nitrogen, all right, and its ability to come down to the other temperature is very slow. And by it coming back down, all right, once it is froze, you take the the liquid nitrogen away from it, and as it starts to try to get back to its original temperature, it becomes like a superconductor. And in that instance, you could put a magnesium magnet, a large one, over the top of it, and it will what? Levitate. It can also spin like a tire and won't even move. It can also start spinning this way. All right? And it will not go away from that superconductor. The superconductor also has the ability to create its own force field. All right? Even in the midst of another field, it creates its own force field. And nothing can enter that force field. Nothing. All right? That's a superconductor, which is a ceramic. The same jars of pottery that you thought you were looking at art, you were actually looking at electrical device. Electrical device emitting strong knowledge if placed in a certain environment. Now, I'm going to leave it there because I know this is going to shut off and I don't have a lot of time on this thing. So utilize that. I'm going to come back and show you, all right, with the liquid nitrogen, with the neodymium magnet, once I can find a nice size one, right, and show you this levitating and all of that, all right. Keep up the good work. Use your head only for personal. What's the name? Don't get involved in no outside ignorance. You know what I'm saying? They can reveal that in their own time. We're ahead of time. Time actually is what they call it when they believe in what they called it. All right? So we believe, we don't believe. We know simply what we know. All right? So y'all continue on and do that which you do. Peace to you all.